Okay, so today's lesson, our plan is it is a Thursday. Our plan for today is the following. To get through today's lesson, it might take most of the block, and then tomorrow I'll give you a work period to catch up on homework. Okay, so then you guys, I'll give you some stuff to work ahead if you want. Okay? Yeah. A zero of a function is a value. Uh-oh. Classic Fix Johnson, it's true. Okay, you know what? I apologize to anybody who's watching this video. Control K. There you go. Now let's try this again. A zero of a function. So what's a zero? I think we talked about this yesterday a little bit. It's the value of the independent variable which makes the function 0. Okay, it could be solving by setting our y to 0. So setting our y to 0, set y to 0, find x. That's the zeros, right? Remember on your calculator when I asked you to find the x-intercept, it said zeros on it. So that really, the zeros and the x-intercepts are the same thing. Okay, so let's solve this function. It says find the 0. So we're setting our y to 0, solving for x. Plus 6 divide by 2. So 6 equals 2x, and then divide by 2, x is 3. Which makes sense. 2 times 3 minus 6, will that make 0? Yes. So connecting roots, zeros, and x-intercepts. Determine the x-intercept of the graph just by looking at it. What is it? 1, 2, 3. Okay, 3. So notice that's our x-intercept. Determine the root of the equation. So the root, we said 2x minus 6. What would that be? What would make this 0? X equals 3. Okay, so what's the point? The point is I want you to understand that roots, zeros, and x-intercepts are all the same thing. They're different words for the exact same thing. Okay? Yes, I'll show you how to do that on your calculator too. Okay, state the connection between the x-intercepts of the graph of y equals 2x minus 6 and the roots of the equation 2x minus 6 equals 0. They are the same thing. So the roots and x-intercepts are the same thing. No, it's more than that. So that's something we can start. The roots and the x-intercepts are the same thing. Using the results of a class example 1, state the connection between the roots, the zeros, and the x-intercepts. So it says, using our example above, a relationship between the root, the 0, and the x-intercepts. How are they related? They're the same thing. So roots, zeros, but we're also including zeros this time, and x-intercepts are the same thing. Okay. So if on an exam, I could find the root, I could say find the x-intercept, or find the zeros. They're all saying the same thing. You should probably put that on your study sheet, right? So whether you're finding, when we're finding let's go back to the top here for a sec. When we're finding the zeros, the roots, or the x-intercept, we do this. And we set y to 0, find x. So that's for finding zeros, roots, or x-intercepts. They're all the same thing. Okay, that's study sheet material. All the same thing. Okay, so we're done one page. Flip her over. Okay, so investigation number 2. So let's look, that was a linear equation. Let's look at a quadratic equation and see if the same thing is true. Nope. Okay. Jax is determining the roots of the equation. Jacques. Jacques? Jacques? Jacques. Oh. We call him Jack. We call him Jack, okay? It's the English for like Cinderella. Okay, okay. Order in the court. He wrote the equation in factored form and using the zero product law to determine the roots of the equation, complete his work. So what did he do? It says he wrote the equation in factored form. Awesome. Okay, let's factor this guy. Is there a greatest common factor? One. It's simple. There is one is the greatest common factor. Two numbers that multiply to what? Negative 6 adds to negative 1. Whenever we multiply to a negative and a positive. Okay, so we could have negative 1, positive 6, or 1 and negative 6. Negative 2, positive 3, or 2 and negative 3. Which one adds to negative 1? 2 and negative 3. So 2 and negative 3. Now, if it's simple, do we have to do any more work? No, it's just x plus 2, x minus 3 equals 0. So what would be the roots? Negative 2 and positive 3 are the roots. Because he was determining the roots. Okay, here's our graph. State the x-intercepts and mark them on the grid. So what is an x-intercept? Where it crosses the x-axis. So here at negative 2 and positive 3. So negative 2 and positive 3 are the x-intercepts here. Kind of. Okay, looking at this function, it says determine the zeros of the function. So the zeros, what do we have to do to find the zeros? Set y to 0. This is our y. Set that to 0. Okay, and then solve. So what would you have to do to find the zeros whenever it's a quadratic? Whenever it's degree 2? The F word. Which F word are we talking about? Not fire truck. F-A-C-T-O-R. Factor. Okay, did you? Sorry. Okay. I got your attention though, right? Didn't I? Okay, so factor. So whenever you have a quadratic, we need to factor. If it was linear, we just could solve for x. It's not that easy. We have to factor with a quadratic. So, but we already factored this before. What was it? X plus 2, x minus 3. So that was x equals negative 2 and positive 3. Ooh, forgot a bracket there. So, what relationship can we make between the x-intercepts, the zeros, and the roots? The same. Okay. Whew. Next page. Doing good, doing good. Fill in the blanks. Okay, guys. The blank of the function, the blank of the graph of the function, and the blank of the corresponding equation y equals 0 are the blank numbers. Okay, you got that one. Same numbers. The graph, which one relates with the graph? X. X-intercepts are from the graph. The zeros of the function and the roots of the corresponding equation, y equals 0, are all the same. Let's fill in some blanks here. So in this question, the x-intercepts were -2 and 3. What's the y-intercept? -6. Okay, the function had zeros. Looking at this. -2, +3. Yeah. And the roots we would have to factor, but because it's already factored for us, -2, +3. Easy, easy peasy. Okay, we're about to make it really interesting soon. At least you admit it. That's the first step to change. Okay, so back on track. Just describe how the features of the graph. You okay? Okay, we need to get going. Are you going to be okay? Okay. Describe how the features of the graphing calculator can be used to determine the zeros. So how could we find the zeros with our graphing calculator? Grab your calculator. You could get y equals 0 and then intersection with the y equals 0. So how do you, but there's a better way. There's an easy way to do it. I did actually tell you before. That's the ironic thing. Okay, I did tell you before how to do this, how to get the zeros. Okay, let's type in our function. Sorry. Okay, yes, I am. All right, 2x squared minus 7x plus 3. And graph. Second trace number 2. So let's write that down. Second, so we plugged in y equals into our calculator. Then second trace number 2 was zeros. Zeros. Okay. Okay, so let's find it on our calculator. So let's find the first one. So go to your graph. Second trace number 2 is 0. Now it says left of the 0. Are we on the left side of the 0? The first 0. Yes, so push enter. Now it says go to the right of it. Now am I on the right of it? Yeah. We're finding out this 0. So we have to be on the right of it. Enter and then make a guess. So you can go back a bit if you want to make a guess. So I get 0.5, which is the same thing as half. So x equals a half. And let's find the other one. So again, on your calculator, you should always use your calculator because you can look at it and maybe guess, but it's always better to go second trace, 2. So now we want to go in the left side. So here's on the left, and there on the right. So the key is to have your arrows have to point in. And then you can make a guess. It's going to be like 3. Okay. X equals 3. Okay, so what would be the roots of the equation? 1/2 and 3. I'm just harassing you, aren't you? X equals a half, x equals 1/3. So draw the graph. So it crossed at 1/2 and 3. 1/2 and 3. Do we know what the y-intercept is? What does it look like the y-intercept is? What? Positive. Well, where could you go to look? Go to your table, or you push trace, 0, enter, it's at 3. So it goes through 1, 2, 3. So this is rough sketch of it. Something like that. So it says state the x-intercepts and the y-intercept of the graph and label them. So this is 3, a half, 3. Okay, next page. No, we're going to keep going. You are going to be okay. This really is. Okay, I know, I'm wondering if I should record a lesson for tomorrow. Okay, we'll see. You're okay. You just, Okay, algebraically determine the zeros of the function. We've been doing this, right? Okay, find the roots of the equation. Algebraically determine the roots of this equation. So we've done this before. So p of x is the same thing as f of x, yeah. Okay, so x equals 0 and x equals, what's the shortcut? Positive 9 over 4. How else could you get the 0 for that one? How could you get the 0 for that one? If you didn't know how to do the shortcut. Okay, so we could set 4x minus 9 equal to 0, right? Because we want to find when this function equals 0. Right, we're looking for when does 0 equal 3x times 4x minus 9? What values of x would make our function 0? Well, this one's obvious. If just x was 0. Here, set this guy to 0 and solve. So add 9 and then divide by 4. And that's how we get 9 over 4. Opposite sign, second over first. Okay, so there's our solution. What would you have to do with this guy? To find the zeros, we have to F-word factor. First question you ask yourself. Greatest common factor. What can you pull out of everybody? 5. So we factor out 5. We're left with x squared plus 15x divided by 5, 3x. And then 20 divided by 5 is 4. So now inside, is that a simple or complex? Simple. Aren't you excited when it's simple? Yeah. I am. Okay, multiplies to -4, adds to Jessica 3. Okay, how can we multiply to -4? -1, 4, or 1 and -4, or -2, +2. So which one is it? -1 and 4. Okay, so when we rewrite this, we write f of x equals, do we still write the 5 in front? Yeah. And now this becomes, it's simple, x minus 1, x plus 4. So what would be the zeros of this equation? We'd set this equal to 0. So what would make our equation 0? 1 and -4. X equals 1, x equals -4. Okay, this is an important question. Algebraically determine the x-intercepts of the graph. State the y-intercept of the graph as well. Okay, how would we get the x-intercepts? No, when x-intercepts is the same thing as what? The zeros. And whenever we do x-intercept zeros or roots, who do we make 0? Y becomes 0. We set y to 0. So this becomes 0 equals 3x squared minus 11x plus 10. So x-intercepts, we set y to 0. Okay, quadratic. We have to factor, and it is complex. Life is complex sometimes, eh? It is. Okay, two numbers and multiply 2 if it's complex. 30 and adds to negative 11. So 30 is a tricky one. Oh, it can be. Okay, so 1 and if it's multiplying to a positive and adding to a negative, both Tim, oh, you seem so defeated. Both negative. Good. So negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. There it is. Negative 5 and negative 6. Because that would multiply to positive 30, add to negative 11. So whenever it multiplies to a positive, the signs have to be the same. And you know what the signs are by looking at what the sum is. The sign of the sum. Okay, so what do we do when it's complex? Replace the middle term. 3x squared. Jesse, I'm going to limit you to your number of comments in class. Get this many. Oh, there's one. Okay. Okay, now what do we do when we have four terms? We do we group it. First two we can divide by x. You can answer questions, Jesse. 3x minus 5. And these ones, not just 2. If the first one's negative, negative 2. So 6 divided by negative 2, positive 3. 10 divided by negative 2, negative 5. Okay, and last step, what can we factor out? We can factor out 3x minus 5. We're left with x minus 2. Do we now know our x-intercepts? X-intercepts are, isn't this cool? 2, just positive 2, yeah, or 2 over 1, and positive 5 over 3. Now it also asks for our y-intercept. So who's to 0? Always the opposite one. So if I'm looking for my x-intercept, y is 0. If you're looking for y-intercept, x is 0. The opposite one is 0. So is it easy to put x is 0 in there? 3 times 0 squared minus 11 times 0 plus 10. What would that come out to be? 0, 0 plus 10 is 10. Remember that last guy is always our y-intercept. 10. Okay, so that means our y-intercept is 10. Okay, homework is pretty short, so it's all 1 to 9. I might give a recording, I'm not sure, for tomorrow. Maybe I will do half of...